This is CPM Precalculus Chapter 2, number 130. Suppose we want to find the area under the curve f of x. Okay, so our curve is f of x over the interval 1 through 10. So 1 is less than or equal to x is less than or equal to 10. Using 25 subintervals. So that's like 25 rectangles. What is the width of each rectangle? Alright, so the first part is just saying what is the width? Well, the width of every rectangle region is going to be b minus a over n. B we know is 10, minus a we know is 1, n we know is 25. That's 9 over 25. Or equivalently, that's I think 0.36 we did earlier. 9 over 25 here is 0.36. That's what we did in number 129 if you finished that one. Okay, so that's the width of each subregion. Alright, part A asks, if this is all true, what will be the height of the first rectangle if we use left endpoint rectangles? Alright, so this one we're not given what f of x is, so we kind of have to answer the question in terms of f of x. Well, let's say f of x, I don't know, looks like this, right? Let's make it a little smooth, right? Let's say this is our f of x, and this is the region 1 through 10 here, right? We're going to have the first rectangle is going to have the height right here, right? Whatever our function is, this is going to be the first rectangle. We know the width is going to be 0.36, and the height is going to be wherever our function hits the rectangle on the left side where x is 1. So since we don't know what our function is, we have to answer this in terms of f. So we know the height is equal to our function. Our function all we know is f, right? F of x, where x equals 1, right? Because x equals 1 gives us the height of our function. So if we plug in x equaling 1, we can answer this. That's the same thing as saying f of 1 as the input. So instead of x, we're saying x is 1. So f is 1. Okay? So the height of the first rectangle is f of 1. Alright, let's go on to part B. Part B says, well, what will be the height of the first rectangle if we use right endpoint rectangles? Alright. So this one we have to kind of look at what the graph is going to look like. F of x, we don't know what it looks like, so I'm going to draw it any way I want. Let's say it looks something like this. Okay? So we're looking at the region 1 through 10 again, and we know the width is 0.36 for each of our rectangles. The first one, though, it doesn't get the height from the left point, it gets it from the right point, right? So the height is up here, and we know that this is not 1, but it's going to be 1 plus the width. So it's going to be 1 plus 0.36 or 1.36, right? That's the x value at the right side of our rectangle. So what is the height going to be? Well, we know the base is 0.36, but the height is going to be our function f. The height is equal to our function f of x when x is equal to 1.36. And we could write that as f of 1.36, right? Instead of x here, we have x equal 1.36. Okay, so that's how we write what the height is. F of 1.36. Let's go on and do part C. Part C says, well, what will the height of the last? Okay, so we're not at the first rectangle now, we're at the last rectangle if we use right endpoint rectangles. Alright, so again here, let's go ahead and see, well, we don't know what f of x is. Again, we're just given it's the curve called f of x. So let's say if this is our curve, right, this is our region 1 through 10. I'm just drawing any curve just to kind of see a picture of what we're looking at. Our last rectangle, we know is going to have a base still of 0.36 units, right? So this is going to be right here. It's going to be 10 minus 0.36. Let's figure out what that is. It should be 10 minus 0.36, 9.64. So I know this is 9.64 because when I add the width, I'm going to get to the next point, right? And since we're using right endpoint rectangles, the height's going to be from the right side when x is 10. So the height of that rectangle, right, is equal to our function f of x when x is 10, so I can just write it as f of 10, right, as we've been doing. And this time we're going all the way to the right side, and we get f of 10. Alright, so let's go on to part D. Part D is saying what is the height again of the last rectangle if we use left endpoint rectangles. So again, let's just look at a picture. We don't know what f of x looks like, but let's say it looks like this. Here's 1 and 10 again. This time, we're going to create a rectangle using the left endpoint. So when we subtract the width, remember we get 9.64, right? We subtract the width. And whatever the height is from this point, we're going to make it the height of our rectangle, right? It's whatever this point, wherever that point touches our curve, is where we get the height of the rectangle from. So the height is going to be where we plug in 9.64 into our function f as the input, right? So that's how we get the height for part D. Alright? Let's go on to part E. E asks, how would your answers change if the interval were, instead of this, right, we're going to call it B to E, and the width instead of 0.36 is just W. So let me move that down here. So again, we have the width, like the interval, let's go ahead and change it, is no longer 1 through 10, right? It's going to be B is less than or equal to X is less than or equal to E. We don't know how many rectangles we have, but we have a width of W, okay? So that's how we're changing it. We're going to say, how would your answers change? So let's go ahead and look at A, right? And say, well, how would the answer change? Well, remember, for part A, we were looking at the height of the first rectangle, right? So we were looking, well, it was f of that first point where our width, not our width, where the region started at 1. So now our answer would be what? Our answer is going to change to be, instead of f at x is 1, it's going to be at f where x is b. So that's going to be f of the first thing is not 1 anymore, right? It's b. Because we're going from B to E, so that height is going to become f of B is going to give us the height. Okay? So we're going to go from f of 1 to f of B. Let's go on to part B. B, remember, says, well, what was the height if we used right endpoint rectangles of that first rectangle? So again, instead of 1 here, we have B, so we're going from B, instead of 10 here we have E, and the width is just W. So this point here is not 1 plus 0.36, it's B plus W, right? So B plus W is going to give us the height for our right endpoint rectangle there. So what is going to be the height? It's going to be our function f at B plus W. Right? just like we did here, but instead of having numbers, we have variables b and w. Okay, so you see how that changes? Let's go on to part C. Part C said what will be the height of the last rectangle if we're using right endpoint rectangles. Well, remember our interval is not 1 through 10, it's b through e, right? So how's our answer going to change? Well, the height from our right endpoint is going to be the height at e. That's going to give us the height of our last rectangle. So now our answer is going to be, instead of f at 10, it's going to be f at the last point in our interval, which is e. Okay, so that is going to be the new part C. And let's go on to part D. Part D asks what will be the height of the last rectangle again, but now if we use left endpoint rectangles. So remember, instead of going from 1 to 10, we're going from B to E. And the width, remember, is now W. So if we're looking at the left endpoint, this height here is given by this point, and instead of 9.64, it's going to be E minus that width. So E minus W is this point right here, that X value. So the height is going to be given when we plug E minus W into our function F. F of E minus W. So when that's the input, that's going to give us the height of our function at that point. Okay? So that's kind of how you would look and change your answers. Changing the interval, we could use variables, right? B through E, and the width of each rectangle if we describe it as W instead of some exact value like 0.36. Alright, so that ends for us CPM Precalculus Chapter 2, number 130.